Hey everyone, welcome back to channel Code with AKJ. Today is day 23 of solving LeetCode 75 challenge. And this is the last problem from the topic hash map or set, that is equal row and column pairs. So let's get started. So given question here, given an zero indexed n cross n integer matrix grid, return the number of pairs Ri Cj such that row Ri and column Cj are equal. A row and column pair is considered equal if they contain the same elements in the same order, that is an equal array. So we'll go through both the brute force approach and the optimal approach. So let's get started with our first example here. So in our first example, that is the grid 321, 176, 277, we need to find the number of pairs of equal row and column. So here we need to return the number of pairs Ricj such that that particular row Ri and column Cj have equal elements. So in this given example, the row and column pairs which has equal elements are 277. That particular pair here is the column 1 and the row 2. Here you can observe that this particular column and this particular row has same elements, and that too in the same order, that is 277 and 277. So this would form a particular pair, row column pair, which has same number of elements and that too in the same order. So we'll return 1 in this example. So coming to the second example, which is a 4 cross 4 matrix. Here we have three equal row and column pairs, that is row 0 and column 0, and row 2 and column 2, and row 3 and column 2. So the values here are 3122, that matches with column 0 with the same 3122 in the same order, and row 2 2422 and column 2 2422, and row 3 2422 and column 2 2422. So in our example 2, we'll return 3 as we have three equal row and column pairs. So this was the problem statement of equal row and column pairs. So let's get started with our brute force approach. In our brute force approach, we'll iterate over each row and column and compare their elements, and we'll count the matching pairs. So let's quickly see our brute force approach with this given example 1. So here I've written the matrix n cross n. The first example, that is 321, 176 and 277. So in our brute force approach, we'll iterate over each row and each column, and we'll compare the elements and we'll count the matching pairs. So we'll use two for loops to iterate over rows and columns. That is, first for outer loop, which will iterate over the rows, and another for loop which iterate over the column elements, and then again a for loop which will compare these two values. So in this way, we'll use three for loops to compare each and every elements of single row parallelly with that particular single column. So here's the code for our brute force approach, where we are gonna iterate over each row and column and we'll compare those values. So this particular for loop is to iterate over rows, and there's another for loop which will iterate over column. We'll also take a bool variable is equal or not, which would be initially true. So we'll again use a for loop which will help us to compare these elements. So we'll check if this grid of I and k is not equals to grid of k or j. So if they are not equal, we'll mark our is equal to false and we'll break from that loop, and we'll move on to the next comparisons. So after finishing our k for loop, if our is equal remains true, it means that particular row and column has same number of elements in same order. So we'll increment our count variable. So this would be our first iteration, and then again we'll move on to our next comparisons, that is first row, second column, and in the same way the first row, third column. So this comparison goes on until we compare each and every row with each and every columns, and we'll increment our count variable if those rows and column values are equal. So this would be our brute force approach. So finally we'll return count after comparing each and every element of each and every row and column values. So generally this outer loop runs in O of n square time complexity, and inner loop takes O of n time complexity. So the overall time complexity of this approach would be O of n cube, and space complexity here would be O of 1. So let's quickly run this code. So let's submit. As you can see, it gets accepted. So Let's quickly dry run this example one with our brute force approach. So generally we'll take is equal bool variable, which would be initially true. We'll compare each and every row with each and every column. So we'll start with our first row. So we'll compare 3 to 1 with 3 columns, that is 312, 277 and 167. So in this way we'll compare first row with 3 columns. Again we'll compare second row with 3 columns, and we'll compare third row with 3 columns. And we'll check whether it matches with the column elements or not. So if it matches, we'll increment our count variable, so which would be initially 0. So first row values are 3 2 1, whether it matches with 3 1 2 or not. So it doesn't matches. So if I try to compare 3 2 1 with 277, doesn't matches. And if we compare 3 2 1 with 167, doesn't matches. Same goes with 176. We'll compare it with 312, 277 and 167. So these two also doesn't matches. So when we try to compare 277 with all the 3 column values, so 277 doesn't matches with 312, 277 matches with 277, so we'll increment our count from 0 to 1, and 277 doesn't matches with 167, so we'll break from that loop. So finally, after finishing our iteration, our count value becomes 1, so we'll return count value 1 in our example 1 case. So here the time complexity of our approach would be O of n cube, and space complexity of our approach would be O of 1. So while this approach is straightforward, it's inefficient for larger grids as it runs in O of n cube time complexity. So let's try to optimize our approach and bring down our time complexity using map or set in our problem statement. So to optimize our approach, we can use hashing. So we'll store each row in the form of vector along with its frequency in our hash map. And again we'll iterate over columns, and we'll again store it in a vector, and we'll compare these values in our hash map. In this way, with the help of hash map, we are gonna check which rows and column values are equal with the help of frequency. So this would be our optimal approach. So let's quickly move on to the code, and let's do a quick dry run on this given example. And finally, we'll do a time complexity and space complexity analysis on both the approaches we have discussed so far. So this is the code for our optimal approach, where we are going to use hash map to store all the rows values into it initially, and finally we'll check columns against these row hash maps whether it already exists in our hash map or not. So if it matches, we'll increment our count variable with its row map frequency value. So initially I've taken the size of a grid. I've also taken a map of vector of int mapping against its frequency, that is int. So initially we'll store rows in a hash map using a single for loop, and we'll also take a count variable which would be initially 0, and finally we'll check each and every column against this row hash map. So we'll store all those column values into our column vector, and finally we'll check in our hash map whether these values exist in the same order or not in our hash map. So if it exists, we'll increment our count variable. So after checking each and every column against our hash map values, we'll return our count variable. So this is a simple code for our optimal approach where we have used map. So let's quickly run this code. It's running fine, so let's submit. As you can see, this gives us successful submission. So here the time complexity would be O of n square, and space complexity would be O of n square. So this optimal solution is much faster and works well even for larger grids. So let's quickly do a dry run on this given example 1, and let's finally analyze the time complexity and space complexity. So let's do a quick dry run with our example 1 here. So we'll take a map which is in the form of vector of int mapping with the int value. So our first row value would be 3 to 1. So initially its frequency would be 1. And our second row value would be 176. The mapping would be 1. And the third row would be 277, and its mapping is 1. So our first step is completed, which is inserting all the rows in our map along with the frequency of each and every row, which will be initially 1 itself. So now for our second step, we'll take all the column values, we'll store it in a vector and we'll compare it with our map values. So our first column value would be 312. We'll check whether 312 exists in our hash map or not. So it does not exist. So we'll move on to our next column, which is 277. So here 277 exists in our hash map. So we'll increment our count value with the frequency of that row value, that is 1. So we'll move on to our final column, that is 167. So 167 does not exist in our hash map. So our count remains 1 itself, and we'll complete our iteration and we'll finally return our count variable which has value 1. So in this given example, our count value becomes 1. So let's try run our second example as well. Our first step here would be to insert all the rows in our hash map along with its frequency. So the first row would be 3122, frequency would be 1. The second row would be 1445 with frequency 1. Third row would be 2422 with frequency 1, and fourth row would be 2422. So it already exists in hash map, so we'll increase its frequency from 1 to 2. So now we'll iterate all the column values and we'll check in our hash map. So the first column value is 3122. So we'll check in our hash map whether it exists or not. So since it exists, we'll increment our count variable from 0 to 1. So our second column value is 1, 4, 4 and 4, and we'll check in our hash map whether it exists or not. So it does not exist, so we'll move on to our next column value, that is 2422. So we'll check whether this exists in our hash map or not. So since it exists, we'll increment our count variable value with its frequency, that is 1 plus 2, which gives us 3. So final column value, that is 2522. We'll check whether this exists in our hash map or not. So since it does not exist, we'll end our iteration, and finally our count variable contains value 3, so we'll return 3. So this was a dry run of our two example 1 and 2. So here the time complexity would be O of n square and space complexity would be O of n square. So let's analyze the time complexity and space complexity of both the approaches we have discussed so far. So in our brute force approach, since we have used 3 for loops, the outer loop to iterate over our rows, the inner loop to iterate over our columns, and again a loop to compare those row and column values. So the time complexity of our brute force approach would be O of n cube, and space complexity would be O of 1, as we have not used external data structure to store the values. So in our optimal approach, where we have used map, the time complexity it took was O of n square, and space complexity was O of n square, as we have used map to store the row values along with its frequency. So in this way, with the help of map, we have reduced our time complexity from O of n cube to n square, while increasing our space complexity from O of 1 to O of n square. And that's it for today's problem. We covered both the brute force approach and the optimal approach for the equal row and column pairs problem. So once try it yourself and let me know your approach in the comments. So if you found this video helpful, don't forget to hit the like button, subscribe to the channel and turn on the notification bell for more coding tutorials. So until next time, keep coding. I'll see you in the next video. Thank you.